All right, so now that we're recording, let's talk about exercise 5, arguably probably one of the easier exercises compared to exercise 3, which really tests your creativity. Exercise 4, that starts to be a little bit more practical, and especially the way that we complete stairs, and it starts to get a little bit more architectural. I would say exercise 5, we're working with topography. And, well, let's just take a look at the assignment together. As you can see, we're essentially going to make something like this with a laser cutter. Nothing of this kind of dexterity, just because we used to do this, but it actually cost a lot of material, it's a lot of cuts, and a lot of time. So to be fair, with this technique, you could actually do something like this, right? However, I've put it on there at least for a small example. But this is actually where we'll start to talk about scale and getting things correct, because that's obviously necessary for something that we're essentially laser cutting, and we want it to be a certain size, and of course we want that to be the right size. In our case, you guys may already know that we're at 1/8 scale equals an inch, and if that sounds just absolutely unfamiliar to you, don't worry, because you'll have it hammered in graphics 1, right? But in this case, I do want to make it simple, and essentially for our observation tower we have 3 parts: the abstract part, the stair part, and of course where it's going. So I do like to have a little bit of fun with that, and there's actually some pretty unique tools that we can use for all of our design studios, so I hope to go over some of those today, like the contours map of San Antonio, which is just an absolute awesome resource to have. But the next exercise is to develop skills of digital design and fabrication in the context of architecture, and to discover the techniques of utilizing the laser cutter for its speed and accuracy in model making. Our first task is to select a 48 feet by 48 feet lot of space anywhere in San Antonio, and of course I'll show the link. It is recommended that each selection is sloped or vertically interesting, and I'll point out what I mean by that. Obviously, if it doesn't have a lot of topography lines, probably don't pick it. The first task will be to trace and to find our contours. The question for selection is, where should your observation tower go? My example today will be of San Pedro Springs Park. However, one thing I would say, guys, is don't try to spend like 3 days on this selecting the right spot. Honestly, it's not for studio. It's a fictitious project. So I had one student spend like a week looking for the right spot, and I go, no, that was not the point, right? It's not a design studio in that sense. So again, just something visually interesting, and I'd stick to somewhere close, maybe to even San Antonio, because there's plenty of interesting topography. However, so for step 1, we'll use the command contour. Can be useful if we already have a surface model. However, typically in studio, we are given our site, and sometimes the topography is on there from the land surveyor. However, sometimes it's not. So after we've traced and created a topo model, we can now prepare the model to be sliced and printed via the laser cutter. So honestly, there's a lot of steps in step 1, so let's just break it down a little bit easier. Last time we talked about stairs, so I'm going to go ahead and delete that. I've already made a copy off to the side of exercise 1, 2, 3, and 4. And again, be organized. So I'm just going to hide those and feel pretty fresh. So the first thing that we need to go is the internet browser, and we will need Google Earth. That way we can actually use some measurements. In my case, I'm going to go over to San Pedro Springs Park. Yes, it's that wonderful giant park right next to us. It's the size of San Antonio College. So it's kind of a big deal. Supposedly it's the 3rd oldest national park. Anyway, don't quote me on that, but it actually goes way back. And to be fair, actually Via Bus used to be a part of it as well, but in the 70s they decided a parking lot for buses was a better idea. Sad face. Anyway, so for today I'm going to actually do my classic corner, because this is of course where the sidewalk ends, and if you've ever been to this part of the park, it's kind of weird. It just has stairs that die off into nowhere. So what better spot to put an observation tower to actually come in and maybe walk down, at least in a safer manner. So I do want to add a little bit of practicality to it. However, this part is pretty visually interesting, so I'm maybe going to do somewhere a little bit down here. Anyway, not important truly the selection, but the size of the selection will start to become very important, because we need exactly 48 feet by 48 feet. And the best way to do that is of course with our measurement tool. So when you hit this measurement tool, you'll notice, I think in default it's in meters. so do make sure that it's not in meters. In my case, I think it's in feet, so we are good to go there. But I essentially want that 48 feet, and I want to get as horizontal as humanly possible. To be fair, it's fake it till you make it, especially in architecture school. So something like that is absolutely fine. We'll hit done, and that's essentially our marker, right? This actually tells us when we take a screenshot where 48 feet exists. Now, to be fair, it doesn't have to be 48 feet, but arguably that would make it a lot simpler, right? Now all we have to do is align a line to a 48-foot line. So in our case, I do want to take a screenshot of this selection. So I'll go ahead and do that. I can either do print screen on Windows or Command Shift and the number 4 and just get a basic screenshot. Now we're going to use that to help us trace, so I'll let that save off into the background. The next website you want to go to is the Hydrology and Contours map of San Antonio. If you were to just type that in Google, it comes right up first try. It's also on the assignment, so you could just copy this as well, and that's the exact link that you need. I don't know why it never became a hyperlink, but maybe that's because this is an image. Anyway, let's go ahead and take these two screenshots, and as you can see, well, it's helpful, but besides really the streets, there's really no other governing lines, right? I mean, don't get me wrong, the orange lines are really great, and boy, do I wish it went outside of Bexar County. No, I'm just kidding, Bexar County. But it really is only limited to Bexar County. So don't get me wrong, this is useful if you're doing a studio project in San Antonio or even somewhere by your house, right? I mean, shoot, you don't even have to pay a land surveyor for some of these topography. You can directly have them from a GIS model, which is great. But in our case, we're going to want to line it up as much as possible. So in my case, I can only zoom in actually so far in this map. However, it's an invaluable resource, right? Essentially having every single elevation line that essentially exists in San Antonio. As you guys know, there was a huge flood in 1927, and ever since then, San Antonio has actually done a lot to mitigate flooding when it comes to San Antonio infrastructure. Anyway, not to digress, but let's take a screenshot of that as well. I'm going to take a slightly bigger one. That way I can make sure I can get some of the street in there or get something that I can start to align up with. So again, go big or go home is not a big deal in this situation. So we'll take that screenshot. And in terms of the internet, that's about all we need in terms of selecting our piece. Oh, I also wanted to point out that this is what I meant by visually interesting in terms of vertical, right? So the more lines, each of those of course indicate a different level or a different plane or a different flat of the elevation of the Earth's surface. So in our case, you want to select something that's maybe not just has one line on it, right? Obviously that only creates 2 layers, and you do want to go anywhere between 10 and 20 layers. I'm going to max you out at 20 layers. But if you do want to have something really like an awesome slope and you want to put this observation tower on it, by all means, challenge yourself in tracing some of these topography lines. Anyway, so let's go over back to Rhino and basically place those 2 images. In my case, I just need to place them real quick first, and then we'll put them to scale. So I'm going to type in picture, enter, and of course take those 2 screenshots. I probably have to take one at a time, no big deal there. And again, just get them on the paper, spacebar to enact the same command again, and let's go ahead and get that other one. Now, at first, we're like, okay, I could have done this in Photoshop, but there's actually a couple qualities that we can do in Rhino that arguably do the exact same thing. So in our case, we do have a known, and we have a lot of unknowns, right? So let's get the known first, and let's go ahead and draw a line. Now it's a very specific line because we want that line to essentially be exactly 48 feet. So you guessed it, right? We'll type in exactly 48 feet, enter, and get that exact dimension. I'll hold shift and make sure that it's relatively the same. Actually almost nailed it, right? Just a little bit bigger. In our case, I want to line up actually the midpoint or the center point of this circle. That's actually where it's taking the measurement. Be very careful. Don't take this side, don't take that side. Do your best to find the exact middle. And if you did want to find the exact middle, of course you could actually draw a circle and get the exact middle by using your center point, right? So, I mean, don't get me wrong, it's technically entirely possible to get a very accurate circle. Anyway, so I'm going to go ahead and move that first. I'm going to take my center point, Boom, got that center point. And align it to at least one side of my 48-foot line. In my case, the next step is one that you'll do 1,000 times, so don't be absolutely worried if it's confusing at first or anything like that. I'll try and break it down pretty slow. So in our case, we need this image to match this 48-foot line. I know it sounds like common sense, but you'd be surprised how many times I have to tell studios over and over again this exact process. And I would say it's probably one of the fundamental processes is just scaling something. To be honest, when it comes to the digital realm, we don't build in scale. Like I wouldn't build a 1/8 scale model and then my professor turns around and goes, oh, now we need a 1/16 model, and be like, I'm not gonna start over and make a whole nother model. No, I'm gonna make my model in the digital realm 1-to-1, which essentially means the true size, the actual size, right? You may have seen it on a chocolate bar too. But we often see something that is called actual size, and we're gonna do the exact same here. So we'll take this image, we'll type in scale, enter, and it's gonna ask for a base point. That base point is that original aligned point. So in our case, it's the image and the line being aligned together. That will be our base point. The next point it's gonna ask for is a reference point. In our case, we already have a reference point, and that's the other side of this circle, right? Where do you want to influence the scale? In my case, I'm gonna hold Shift and do my best to click on the middle, right? That's pretty close. The next step is, okay, well now where do you want that reference point to be? Well, now I want this 48-foot line to equal 48 feet. Lock in, click, and voila. We have a scale drawing, just like that. To be fair, there's many other ways you can scale drawings, but arguably I would say this one's probably the easiest way. From there, we're not finished. We do need to scale this one. However, it didn't have a measurement tool in there, right? There is no measurement tool in here, at least not yet. Maybe it's coming soon, but I doubt it. Don't want to hold my breath because this is probably the 5th year that I've done this. So in our case, we do need to align those images and fake it till we make it, right? We do have the street here, and we'll do our best to essentially try to line up to that piece. Now I should have maybe taken a bigger screenshot here to again maybe get the other side of the road. Keep that in mind because you'll have a studio project where there are no roads and you're like, okay, now what do I go to? Again, in the words of Professor Escamilla, fake it till you make it. Anyway. However, it might be easier to see if we add some properties to these. So for instance, I can click on the image itself. As you guys know, I can go to the materials property and actually increase the transparency, which again can be really helpful when I'm trying to align certain drawings. So again, I'm going to add transparency to both of these. That way I can at least fake it a little bit better. In my case, I'm going to use the gumball tool and basically just do my best to scale that to the street first. And there is no shame in making another screenshot. If you didn't get enough space there, that's okay. But again, I'm going to try and fake it till I make it. Do my best to line those up. And sometimes you'll actually even see it in the street, right? That leveling, if you will, of that level. Eventually you start to look at so many topography lines that you really start to understand what's going on, which is, of course, a nice architectural trait. In my case, for the sake of tutorial, we'll call it even there. Now, the next piece that we need is, we only need that 48 by 48. So in my case, my 48's not really selecting a lot of lines here. That's probably fine for today. But in my case, I'm going to fake it till I make it just a little bit more and say that this is actually a little bit smaller. That way I can get some of the interesting context in there. So let's say that's there. Anyway, fake it till we make it, and we get a couple of more lines in there. Arguably, let's fake it at least for the sake of tutorial. Again, you don't have to shift these. I'm just, of course, want to make it a little bit more visually interesting for what we're doing today. And that's a little bit more fair. Next, once I've aligned those two, I'm going to make a rectangle. That's essentially 48 by 48. So I'll make it over here. 48 feet, enter. 48 feet, enter. Awesome. So there's that perfect scaled square that I need. I'm going to go ahead and move it. So move. We'll take that point and we'll align it up to our previous base point. Voila. We'll take that, trim it, and get rid of the image parts that we don't need. Sweet. That's all I need, right? Fair enough. Let's make a copy because nobody wants to do that all over again. Because I might mess up. The next thing I need to do is trace it. So in my case, I'd probably suggest, not probably, I would suggest, and let's get that a little bit better for the recording. There we go. Let's go over to our layers tool and let's add another layer. In my case, topography. And you know, I'm a sucker for green for topography, so I'm going to go ahead and use green today. And essentially all we have to do is trace it. Now I would say make sure that it is level and flat on the base, because if it's anywhere kind of up or anywhere kind of down, it does start to get a little weird. So be cognizant of that. But let's go ahead and trace it. So in my case, I'm going to use this wonderful curve and essentially start really outside of it, and you'll see what I mean by that, because we can always trim it. We can't really just make lines longer. I mean, that takes a little bit more time, and arguably more time than it should. In my case, make sure that you're on topography, and let's go ahead and trace. So in my case, I always start outside, and I would probably turn some of these off. We don't necessarily need them right now, at least for tracing. We don't want it to accidentally line up with something that we don't want it to. So in fact, I can completely turn it off. In my case, do your best to kind of follow the line. Keep in mind all of these control points that we're making, you can further control them. So again, be as accurate as possible, but no, you don't have to sit there and draw a million points. We can fake it till we make it, and after all, these will be eventually the lines that we laser cut. So accuracy is nice, especially for studio. Now I'll do my best to small talk this one and trace it real quick. I chose a minimal amount of lines for the sake of tutorial, not necessarily what I want you guys to do. Again, I would aim for 10 to 20 lines. So ballpark it. To be completely honest, you can actually make up your own if you are in D4 or D3, or would like to use something more relatable, like maybe a site in studio. That's totally fine. But yes, here's the fun part where we put on the music, maybe the show in the background, and we trace away. However, what's also really nice is if you have a Wacom screen, as some of you guys may be sitting at, you can actually trace this by hand with the pencil. Of course, the studio pencil. Don't use a regular pencil. And again, fake it till I make it, and for the sake of tutorial, we'll go as fast as possible. I would like to introduce the laser cutter today on this video, or maybe as a separate video. Hopefully it's working today. I checked in yesterday, so it should be okay. But you know how computers can be. Anyway, for the sake of tutorial, I think this one will be my last line, and we'll call it a day on tracing. Sweet. Alright, next step. Always making a copy, because again, I'm always messing up. So let's get rid of the image for now. We don't need those anymore, but it's okay, we still have them just in case we do mess up. In my case, I do know this site pretty well, and I know that it actually slopes up. One thing to double check is, well, that contours map. Sometimes that screenshot that you take has absolutely no markers on it, so you might have to refer back to this map and actually go, wait, is 700 more than 696? Well, yes it is. And what that tells us is that this is sloping up. It's going up in elevation from sea level, right? Which is of course 0, or at least average 0 for everybody, not to get too technical. But it's going up, so it's sloping up, and the best way to maybe see that, at least for the sake of tutorial, is to start to move them up. We're essentially creating a wireframe, if you will, of this selection. So in my case, let's move that up. Another thing that might be nice is just using one of your views to, of course, move that up. So in my case, I'm going to start with this one at 0, and I really kind of need a 0 plane, right? Or maybe even a 0 line. That's kind of outside the realm. So in my case, like I said, fake it till we make it. I'm just going to make one that's kind of outside of the realm. And that will define our 0 for us. So this one will actually be 1 foot up. Each of those lines, those topography lines, stands for 1 foot of elevation. Now be very careful, because some topography maps, they stand for 2 feet or 5 feet or gosh, 10 feet, right? There's all kinds of different surveys. So just make sure that you're keeping track of something like that, because that will definitely change the slope. In our case, that will be our 0, so we just need to add 1. So I'm going to move it right here, and 12 inches, enter, hold shift, and click. Essentially starting to make a sloped model. You guessed it, this one's going to go up 2 feet. Move, 24 inches, or 2 feet, and 3 feet, and so on and so forth. Arguably pretty simple. So 4 feet, and again, I'm just hitting spacebar because at this point, I'm just moving over and over again. And lastly, 5 feet. Holding shift, that way I know that it actually goes up. And for the most part, I bet you could even start to visualize that there's kind of this wireframe pattern. To be fair, there's a couple of ways that we can actually do topography. So one of the first arguable ways is, well, we can just make layers, right? I mean, we could just complete this layer and essentially just extrude a closed curve. We could definitely do that. Another way to think about it is, well, you can actually loft a surface. So I'm going to go ahead and make a copy and try it 2 different ways. So from here, I can take every line, well, every topography line, and loft it. Some of you guys may remember loft from exercise 2, but we can definitely start to make a surface out of this. Now, it's not always perfect, as you can see, so you might actually have to play around with it a little bit, maybe close the loft, maybe not, maybe rebuild it, maybe simplify it. And to be fair, it's not always going to work. Sometimes it does overlap on itself, not a big deal, right? However, what's kind of nice about that is if I'm doing a render for, say, my studio, I can go with something a little bit more traditional and actually starts to look like maybe a sloped surface besides maybe this overhang going on. And I could dial in and, you know, obviously fix that. But for the sake of tutorial today, not super important. Oh, didn't want to get rid of that. Let's redo that loft. There we go. So maybe that works, maybe it doesn't, but good thing we did an overhang, because now I can chop that off. You know, not a big deal there. However, that may work for some, may work for nobody. So that's why I show multiple methods. In my case, the second one, I'm going to call the cardboard method. I've dubbed it the cardboard method. But essentially, we need to make each piece out of cardboard. So in my case, I'm going to do a rectangle for my base. And this is where I'll turn on maybe some of my other points. So that one would be my base layer. And I'd essentially get rid of this one, right? That way I didn't get too confused with all the green and purple lines. The next one that I want to do is essentially trace that around. So you'll see what I mean by this. I'll basically use a polygonal tool, and I'll need intersection there. So intersection, and I'll hold shift and basically just trace it real quick, right back to that initial line. Enter. I'll select that line and this line and trim them. Arguably a little bit more clicks, but easier, right? I'll take these two and of course join them. That one, and of course that one, and join them. Now if we did everything correctly, we should see actually a pretty level plane. Uh-oh. I think it actually got stuck on this other plane. That's okay. What do we do if we have different levels, right? Because like if you try to cap that, it's not going to cap right, it's not going to be flat. So in our case, what we could do is go back to our top view. We could say make 2D and apply it and get a flat one. Another thing to be said is, well, we could use the original before we lifted those up, and we can actually do this method first and then just lift them up 1 foot. Arguably, that might be easier. So let's go ahead and do so. Good thing I made a copy. Let's copy it and try it again. Get rid of my images. And we'll actually go ahead and trace it here. That might be actually a little bit easier, especially for some of us. So again, it's going to stay on that flat plane. And we're essentially going to trace that a couple of times, basically completing the cardboard pieces and essentially stopping at each of the start of the other line. Again, multiple pieces. And as you can imagine, as soon as you have 800 pieces, this becomes quite the task. But, of course, not what we have for today. Awesome. So from there, I'll take each piece. You can actually just select all of it and trim. And get rid of the leftovers, since we're no longer lofting the surface and going with the cardboard method. Sweet. Guess we don't need that circle anymore. We'll take that one instead. And as you can see, it's still pretty flat. So one thing that's kind of nice is we can take each of those curves and join them. You can type in J for join, or just type in join. Make sure you get the right curve that's stopping on the other one, and join. And I'm essentially just joining those curves. That way I have some closed curves for my steps. Now, yes, I still need to lift these up, so go back to these views, and we'll get rid of that loft for now because it's kind of getting in the way. There we go. And maybe let's just delete that one altogether. After all, we just made another one, so sweet. But we need to take each one and basically move it up the same way. So move 12 inches or 1 foot. Make sure it goes up 2 feet. Make sure it goes up 3 feet, so on and so forth. And don't lose track, especially if you have 800 topography lines. Go 4 feet and 5 feet. Now what's kind of nice about the cardboard method is this part. Once you have all closed loops, you really start to get a feel of this object, right? But you could take the entire thing, extrude curve, and get it all in one swoop. So basically we just want to go up 1 foot. Voila. We have an entire digital model. So again, arguably, even those are a little bit more tracing work, I say, for the cardboard method, arguably probably the easiest way to visualize something, and it does look pretty good for studio, right? Definitely gets the point across as topography. Essentially, this is the method that we do by hand, but today we'll actually do it on the laser cutter. So we need to prepare that for the laser cutter because we can't just highlight it and throw it at the laser cutter. It won't know what to do. Essentially, the laser cutter is a printer, but instead of ink, it has lasers that cut and burn. But in our case, we need to prepare it. So the best way to prepare it is, well, for the specific laser cutter that you're about to print on. Now, it does have a true size. In our case, it's a 12 by 24 ratio. So in my case, I want to get these pieces first. So I'm going to go ahead and copy it. That way I don't accidentally lose that. And basically start to separate these pieces. As you can imagine, I have 1, I got 2 pieces, and I just need to basically lay them out as close as possible, to be honest. So pretty close. And that's to, of course, just reduce the amount of material that I'm using for this model. Obviously, you wouldn't want to use one piece, and all of this eventually becomes money. So I'm not sure why that piece is looking weird. Let's make sure it's correct. It's looking a little funky. No? It looks a little funky. It's like showing up there, but huh. That's not ideal. Let's go ahead and delete that. Let's see if we can make something a little bit better. Maybe closed curve is the issue? Guess not. Let's do that one more time. Extrude. Yep, now it's looking like the whole thing. Okay, there we go. Maybe just a graphics card error. I am screen recording, so those things do happen. But let's also get that piece. And we're done. No, I'm just kidding. From here, we have to make 2D because, well, if you look at it, it's still kind of like sloping, right? It maintained that Z-axis, and we definitely don't want that. So we'll go to our top, and make 2D. Maintain source layers, that's fine. Group objects, of course, fine. And we'll apply. From there, we're very close. We've got our pieces. However, there's still actual size. I mean, if we sent this to the laser cutter right now, it'd be like error, because our laser cutter is only 1 foot by 2 feet, or sorry, 2 feet in the X, 1 foot in the Y, so 24 by 12. So in our case, we need to do that. And arguably, I also have a trick up my sleeve for that. And well, we can calculate it based on the paper size. So in my case, I'm going to make 2 more layers, one called cut and one called score. Now, we don't actually have any scoring today, but we'll switch this to an actual blue. Don't just choose any blue. In fact, our laser cutter upstairs only reads red and blue. For some reason, it's just been actually set to that way. But if you accidentally choose lavender or even an off blue, it just won't even read it. So again, it has to be the exact color blue and the exact color red. So just for the sake of tutorial, I want to make sure that you guys know that score is blue and cutting is red. And make sure you actually get those exact colors. In fact, I don't think I got the exact color there. Ooh. Make sure it is, of course, the exact color. Awesome. So from there, I'll switch this to cut because that is what I want to do. Right click, change object layer, and we're very close here. The next is kind of the bounding box, and usually I leave that in black, so I'm going to go back to my 0 and basically just make a rectangle. Now, I need to make a very specific rectangle, and I know that this model is at 1/8 scale. What that essentially means is for every 1/8 inch, that equals a foot at this scale, right? So one thing we could do is actually do all the math and the calculations and things like this, or we can just times the paper length by 8, right? So in our case, we have a 12 by 24. You can pull out your fancy calculators. It's funny, my 90s teacher said we'd never have calculators in our pocket, and now we do. However, so I'll take 24 inches times 8, and that'll be 192 feet. So 192, foot symbol, enter. Awesome. And we'll take 12 inches, or divide by 2, you know, just using our math linguistics, and we'll do 96 feet. Awesome. Now at 1/8 scale, this is scaling our objects perfectly. And you'll see what I mean when we go up to the laser cutter today. Now what's kind of nice is now when I dimension this, at least on the computer, it shows a true dimension of 48 feet. And now it's at scale for the laser cutter when we send it to that paper size. If it sounds confusing, it may get less confusing as we go upstairs and you start to see it in action, right? However, keep in mind you won't even be doing something like this until D3, arguably maybe at the end of D2. But for the sake of tutorial today, I would say this actually ends the part that we need for laser cutting. So just to recap, we went over tracing the topography lines and choosing. We went over a loft method versus a cardboard method and why those would be useful. And then of course making our pieces available for the laser cutter. Now you'll see that they do and require to be absolutely flat lines. One more requirement, and good thing we made a layer for it. We'll actually expand on this layer a little bit. There are a couple of caveats, such as we need it to be a continuous line. If it's not, and it is by default, make sure that it is. The next thing that we need to do is of course change the properties of the print width. So I'll choose print width and make sure that it's hairline. That's very important. And that's really just for that layer. That's because the accuracy of the laser cutter upstairs is 0.0001, which is about the size of a hair. In our case, we'll hit apply, and that's essentially good to go. So not too shabby there. From here, I'm going to actually export my lines to my USB drive, and we'll meet and continue this video upstairs. So at least for the sake of today, I'm going to export it. So file export selected. Good, we're making good time as well. So save as, and we'll call it laser cutter lines exercise 4, or sorry, exercise 5, and turn that into a very specific piece. You can either use a DWG or you can even open up a Rhino file. So in my case, I'm just going to save it as a Rhino file, but obviously eliminate everything else that I had in the file. That way it's not too big and not too small. In my case, I'm not sure if the Rhino upstairs is at Rhino 8, so I'm going to save it as a Rhino 6 or even a Rhino 5, just in case the computer that I'm using doesn't have the same software. So I'd recommend that you actually save it a couple times in different places. So CVP, Rhino 6 file, and that's looking pretty good. Export, and we're good to go. So from here, I will pause the video. I'm going to kind of do two things. I'm going to ask somebody to record me as well. That way we can get a laser cutter tutorial again and add to my plethora of laser cutter tutorials. But also I want to add it to the end of this video. That way it's nice and cohesive and clear. So, any questions about that so far, guys? Pretty clear, I think. So we'll end that or pause that for here. Welcome. This is the laser cutter. It's a very expensive machine. To be completely honest with you, it's about 30 grand. So there's a reason we have a tutorial based on it. Now at San Antonio College, you get to use it yourself, and that's pretty amazing because at any other school like UTSA, Texas Tech, U of H, they don't even let you breathe on it, right? Let alone even open it. So just to explain a little bit of how the laser cutter works, is essentially this is our laser. It's got a CO2 laser in the back and it shoots it, hits these mirrors, and you'll see this little red dot, right? Very familiar, laser pointer that, you maybe mess with your cat a little bit. And essentially we use that to align this tool. Now, for the most part, this won't turn on unless the computer's actually connected. So keep that in mind. I mean, it's just kind of the fail-safe. If you're pressing on and it doesn't turn on, probably means that needs to be set up, right? Second thing, you should always work in groups of 2 and never ever leave it cutting alone, right? Because there's always a risk of fire, and that's actually why there's some glass here, so that you can look in and see if there is a fire. To be fair, it is pretty rare. However, a year ago, we had somebody shoot 6,000 lines in the same spot. She also didn't take my class. She had no business and didn't even take the tutorial, right? So she ruined the entire machine and cost us about $3,000, right? So keep in mind, always work in groups of 2 and always be in here for the cuts, whether it's 5 minutes long or sometimes 45 minutes long, depending on how many cuts that you do have. But just to explain the laser, it is pretty fail-safe. In fact, the laser won't even turn on if this is up, right? So, first things first, let's open up our file. In my case, this is the world's slowest computer. If you have this terrible HP, and I don't know why it's been replaced this way, please don't ever turn it off. Please don't ever log out, because it literally takes 35 minutes to get set up, and thank God somebody yesterday left it on, right? Because this tutorial wouldn't work. So in our case, we want to open up that file first. I'm going to go ahead and close that. Can't really close it. And luckily we do have Rhino 8. So even though we saved it as Rhino 6, we're good for today, right? So I'm going to go to Rhino 8. And as you can see, this is not the strongest computer. In fact, this computer was here when I was here. So it's pretty old. In our case, it may take a second. Well, let's go ahead and open up that file that I just saved. Wait for it. We'll go to CVP, go to Laser Cutter Exercise 5, and of course no issues opening up this Rhino file. That looks pretty good, but we can't just print it out from here. We do need to select our top view and go from there. So to be honest, we don't have to select anything. And just as I was saying before, this basically is a printer, except instead of ink, it has lasers. Right? In our case, we'll go to File, Print. And by default, this is the only printer that it has. Awesome, we don't have to go through printers or anything like that. The thing you'll want to select is the window, right? So under View and Output Scale, you'll select Window and Set. In our case, this only is one size paper, so it's only going to be 24 by 12. That's it. Nothing bigger, nothing less. In fact, if it is, it won't even cut it. So be careful with that. That's why we set this bounding box first. essentially I want to click on two corners, so end to end, hit enter, and voila, there it is. Already perfectly to scale. And of course, if you didn't see my previous video, make sure that you see the exercise 4, because it goes over these line types and some of the specifics with that. Also, all my other laser cutter tutorials have that too. So, in my case, I'm just going to hit print, and it's going to send it away. I'm just kidding. Nothing happens. Right? In our case, it sent it to this program that's kind of the middleman for this machine in the computer, called UCP. Honestly, I don't know why it's called that, but we'll hit UCP and you'll see, voila, magically right there. However, you'll also notice that every single person's file is on here, right? So keep in mind, it can get pretty dicey, and whoa, today we hit number 4,000. That's kind of cool. So we're our lucky customer of the 4,000th cut, right, of this machine. Kind of cool. Anyway, that's looking pretty good. The next thing I want to find is, of course, my cardboard, right? In my case, this is a pretty good thickness. It looks about 1/8 inch. And to be fair, we do have some scraps, and arguably try your best to use some scraps, right? One thing I would say that is good practice is to actually test your cuts and scores on a scratch piece first. Obviously, sometimes this piece you're using is like $25 basswood, and you definitely don't want to mess that up. So make sure you find a comparable material and test your numbers or settings first. So we'll get into that. But this one, don't do what I'm doing today. But essentially, it looks like we have a piece that's a little bigger than the tray. Let's see if we can maybe find a smaller piece. It's actually looking okay for today. But as you can see, pretty interesting what you can do with a laser cutter. For today, I'm not actually going to get every single piece, as you can see. But for a test, I don't think it's too shabby. Now, in my case, what you might want to see is that this is our 0, point. Now, this little hexagonal tray that you see is exactly 24 by 12. You want to do your best to align that, right? So, I mean, as close as humanly perfectly as possible. And that's looking pretty good. You also want to make sure that it's completely flat, because if it starts to bow out, that's going to cause a different distance, as I'm moving across the sheet. So do your best to have a very maybe nice, perfect piece, right? Which in itself can be kind of hard to find. In our case, this is pretty good. We got it lined up 0, 0, and good to go. Well, the next thing that we do is we have to align this laser somewhere. In fact, you'll notice on these settings, we have a couple. We can home it, which should already be homed, but if you notice it not going to the 0, 0 point, sometimes hitting home XY can help kind of recalibrate it. What I would say never click on is home Z, because we don't have a sensor for that and it'll just keep going. So you'll have to hit stop or hit that button again if you accidentally press it. Not a big deal. Worst case scenario, usually just opening the device actually stops a lot of the operations from happening. But in our case, I can use this focus laser or focus view, and I can actually select a point on here and it'll immediately go to that exact point. What's kind of nice about that is I can immediately see that, well, I'm not going to get that part of the line, right? Because of course in my case, there's material missing. However, we can also double check that it is going to actually hit the piece, right? The last thing we want to do before we cut is calibrate the Z axis, right? That's the exact length between the laser and the material itself. That's super important because some material is really thick, some material is very thin, and that 2 inches needs to be exact, which is why I've 3D printed this little device. Please don't lose it. But just to explain it, from here to this very small edge up here is 2 inches. So let's put it relatively to the center of the material and do our best. Open, right? One thing I would say about this flimsy piece of aluminum, make sure that it's down before you cut. But of course you need to lift it up, and it has little magnets to kind of make sure that it's in there. We'll take that lid, we'll take that piece, and we'll do our best to kind of get it on there, right? right now it's actually pretty flush if I push the material down. We'll use these down arrows. Now what that does is actually lowers the bed or raises the bed. And you can kind of guess, obviously that lowers the bed, raises the bed. So in my case, you can hold it and it moves quite quickly. But in my case, what I'm looking for, and you might want to get a little close, Esteban, what we're looking for is actually the flush element of this piece to be flush with this red surface, right? So right now, as you can see, it's not really flush. And I'll basically move up one little tick at a time until it is flush. Oh, you see how it popped off like that? That means it's not flush, so I'll come back down. And it's honestly something that you can kind of feel when your finger's here, when it's flush and when it's not. Again, do your best to make sure that it is flush. And voila, right? We have exactly 2 inches between the material and now that very bottom edge. And that's actually what that 2.0 stands for, 2 inches laser cut. We'll go ahead and close it. We'll go ahead and close it. Last but not least, and ours is already on, is the exhaust. Obviously you don't want to cut without the exhaust on because it's going to have debris, material, and unfortunately a lot of fumes that arguably aren't good for you, but make sure that it is of course on. In my case, from here, lastly what we have is the settings for that specific material. So we'll go to settings. And to be fair, there's a catalog of materials. However, not every single material that you can possibly use is in there. To be completely fair with you, if you type in 50-watt machine into, say, I don't know, Perplexity AI model, and you go, I'm working on a CO2 laser cutter, 50 watts, what kind of power or settings should I need for blank? Maybe 1/8 inch cardboard. And that's actually pretty good as well. In our case, we'll actually go to natural. We'll go to paper or mat board, and we'll look for those P's, right? Obviously it's not under paper. Let's try some mat board. And to be fair, as long as you know the decimals of inches, which is 0.125 inches, we can set some of those things pretty nicely, right? Obviously make sure you're in inches. And this is where we start to see those, right? The raster, you always want to skip, never want to raster. Vector engraving, that's what I meant by scoring, right? So we can actually skip that too because we don't have any blue lines. And when it comes to the actual cutting, I typically add 5%. But since we have a brand new CO2, it is super powerful. So you probably don't actually have to add anything. So we'll go back down to 0. Or try to. There we go. We'll hit apply, and we'll press OK. Now the machine is set up. Now we get to press a big green button, and it'll basically play those out. It's basically aligning itself right now first. It's going to go all the way to the other side. You can't really see that. Make sure you don't see any flames. Right. If you start to see really big flames, just coming from almost like a candle wick, like the size of a candle, that's okay. But as soon as the material catches on fire, you open this thing up immediately. And as you can see, it's cutting each piece beautifully, I might add. Like those little flames you see, totally fine. But yeah, if you see a flame for more than 5 seconds, just open it up. It's actually getting pretty close there. And that, just like that, it's all done. Once you stop hearing the machine really obviously go, and you'll see actually an indication that the timer's done. It took 1 minute and 39 seconds. You know how long that would have took by hand?
Like
A lot
10
more.
minutes.
A lot more, right? So I'll open that up. We'll take our piece out. Scrap piece. And voila, look at that, guys. Stack those layers just like we did in our CAD program. And as you can see, we're missing some pieces, but glue it together and bam, assignment 5 is done. Not bad, right? Fairly easy. Any questions, guys? Thank you. Yes, and actually, and he just did a really good thing. Always clean the bed. Always leave this place better and cleaner than you found it. I mean, that goes without saying. You hear that in first grade. I don't know where it fell off, but you know, often this area is really dirty. Keep in mind, the name of this room is 651 MLC. Now, for my computer graphics class and all sophomores, they have access to this room. So it's usually locked. So make sure you call dispatch with 2 people and go ahead and use the laser cutter. But as you can see, I'll pass that around. It's flawless and the exact size of it. Yes, please.
Where's the nearest fire extinction, just in case?
We should totally have one. You have a really good point. We don't have one, so I'm gonna find one.
I just bring mine. Like.
Of course. Good question, though. And that's exactly. Honestly, as soon as you open this, it's going to turn off the laser and it's going to cut the circulation of air. So, should be okay.
You never know.
But yes, you're right. You never know. Good questions. Any other questions? Yes, please. Yeah. So, for the settings, that depends on the material. So, make sure that you go through the material library. And it's honestly a little weird, right? To be completely honest with you, like sometimes you can find, honestly, it's not going to cut metal. I don't know why metal's on there. It's not going to cut metal, right? Most of the time, it's going to hit cardboard, board. The thickest basswood that you can use, by the way, is 1/8 inch. So keep in mind, it's not going to do that 1/4 inch basswood. Yes.
Can we bring our own material?
Absolutely. In fact, yes, this is required. You're not going to be supplied material. But just to answer his question, you'll want to go through the material library, and you'll just need to set the thickness. That's it. Fair enough. Keep in mind, the first part of exercise 4 has some of the line issues and layer issues that we need to settle before we bring it into material, which is basically just turning it into a hairline. So, great question. Anything else, guys?
So just making sure whenever you go in rhino, you put it in top view, you want to make sure it's only like one line that it'll be cut.
Very good observation there. So we definitely, I know some of you, I'm looking at you, right? You have like 8 lines in one spot. Make sure you make 2D, that way it does turn it into one instance. That's actually how we burned the laser cutter last time. It's because again, that girl she had 6,000 lines in one spot. So it sat there for 4 hours and of course it burned the crap out of this machine. So be very careful, and that's a really good point. Make sure that you only have one line that it's cutting, because it really will sit there and cut every single one.
6,000.
And usually you can kind of tell. Like for instance, it does give you a preview time of your cuts, and if you see it, it's like, as you can see, those lines took about less than 2 minutes. If you see it upwards of 25 minutes, 45 minutes, that should be a good indication, like, wait a minute. I think I've either got way too many lines in here, right? That, and you don't want to sit here for 45 minutes, right? Really great observation. Anything else, guys? Yes, please.
So depending on, you move the settings for whatever material it is, so long as it's accurate, should it be able to, like that's what you said, the highest would be 1/8 of an inch?
Correct.
Is it fair to say that it will just cut through it the first time?
Yes, and you'll actually want to change the speed. So what it automatically does when you select a material is it's dialing in the settings for that material. It knows to actually slow it down and increase power. So it's going to do that all automatically based on what you select. So for instance, let's say it's that basswood, right? So we're actually going to go to wood, we're gonna go to, actually this one's always been debated. I go with hardwood, that way I know that it's gonna go through. And I usually choose like a maple or general hardwoods. However, since we have a new laser cutter, honestly, medium wood's probably fine. You can see that there's birch, medium woods, alder. For the most part, your plywood board, those are birch, right? Birch plywood, which is why they're a little pricey. We don't normally use softwoods, and you'll find like balsa wood in here. We never use balsa wood. Don't use balsa wood in your models. It's just flimsy. And there's very hard wood like teak and iron, but it tries to be pretty specific. But unfortunately, once you click on these, there's no real indication of speed or anything like that. So just kind of keep that in mind that it is based on the material. Great question though. And again, material thickness is absolute key. And in your case, making sure that you definitely get that exact 2 inches with this piece will definitely ensure a great cut. Fantastic questions. Thank you for being here, both of you. Was there anything else?
I guess just for me, if you could put it, how you used it the first time, the 2-inch thing?
Sure.
I wasn't able to quite see that.
Yeah, of course. We could probably end the video for today, but I'll go ahead and do that part again.